Hello everyone, Mr. Schultz here for Integrated Math 2. We're doing notes for 4.3, coordinates in space. Don't forget to make sure that you wrote your first name and your last name, as well as your period number at the top. So once again, this is coordinates in space. So just a reminder, an ordered pair can be written in the following format: x, comma, y, and it represents where a certain point is in two-dimensional space. So that looks like this. It's like, hey, if I say, hey, 3, comma, 4, then that would be like 1, 2, 3, 1, 2, 3, 4, and it'd be count the x, count the y, put the dot done. So an ordered triple can be written in the following format: x, comma, y, comma, z, and it represents where a certain point is in three-dimensional space. And so we kind of think of it like this: like you have your two-dimensional right here, we have our x and we have our y, and then coming straight up through, so there's a table right here, coming straight up through the table right here, we have our z. So instead of quadrants, which is in two-dimensional space, where it's like one, let me try, give me a second, where it's 1, and then 2, and then 3, and then 4. Here's our x and our y. Three-dimensional space has octants. So it's like, hey, here's 1, so it's like, this is like a table right here, and we have below it and above it. So above it, we have 1. So we have like over here 1, over here 2, over here 3, over here 4, and it's above. And then below, that's twice as much. So it's octant. So there's 8 little spaces that we could explain about. So hey, let's practice graphing in 3 dimensions. So example 1, graph a rectangular solid in space. Well, 3 dimensions. So if you were to graph this is going to be A, the 2 is the x, so we figure out, all right, which one of these is the x? Oh, this one. And which way is positive and negative? Because it just depends on how your graph is being made. So I see 2, so 1, 2 right there. And then 1, so the y is 1. So I know that the y right here is going to be like right there. And then the other one is 5. So then I know it's going to be right. So this is where it gets tough. So we have 2 and then 1 right here, and then right about there. So I'd be like, all right there. So this would be A right here. All right, so the next point right here is we have B right here. It's going to be 2, 2, 0, 5. And that's going to be like right about right there. There's B. Next one I have is 0, 0, 5. We'll call this C. And so that's going to be right here. So this guy is going to go through to here. And this is where we come into this issue of, maybe we should use 3-dimensional spaces. Kind of tough to represent on a 2-dimensional paper right here. The next part right here is this is going to go to 0, 1, 5. It's going to be our D right there. And so this is going to go right there. And this goes over there. Maybe if we used a different color. Now it is going to go straight, so it's going to go straight down. Like E is going to be, so let me write this in. E is going to be 2, 1, and 0. So at the moment, so if I connect these, at the moment, we just created up there, we just created this right here. Now we're going to come down and do E, which will be right about here. So if I go down, E will be at 2 for the x, 1, 2, and then 1. And so it doesn't look like it, but it's going to be right there. And so we're kind of going straight down right there. And now we're going to go and we're going to do our other 3 points, and those 3 points will match up. So E matched up with A. Now B is going to be, well, not B, F. F is going to be 2, 0, 0. So that one's straight down right here. 2, 0, 0 right here. And this matches up right there. So now that's what this looks right here, except it's kind of off a little bit. That's okay. So now we're going to come around and we're going to do G. Now right up here, G is going to be our origin, 0, 0, 0. So right here. So right there, it comes right there. And this comes straight down right there. So that's this right here. This final one right here, that's going to be H. And H is going to be looking at D right here, 0, 1, and there's not going to be anything going up, so it's 0, 1, 0. So I know it's going to hit right there. It comes down. And so looking at it, it's kind of hard to see it, but it should look like a rectangular solid going up like this. Now it's okay if it's a little off, but try your best. Now here's C right here. I want you, well, not C, but here's number 2. I want you to try your best. So I'm going to pause right now. All right, now we're going to continue. Now if you didn't finish, go ahead and do it for homework. Let's go on. So now example 2 and 3 is just like we did previously. So example 2, distance formula, but in space. So remember the distance formula. It looks like that. We have 2 points, x1, y1, x2, y2. So we're going to take the second point, x value, minus by the first x value, square it, and we're going to do the y value of the second one minus the y value of the first one, and then square it, and then square root that, and we'll get our distance. So let's actually read this part. Basically, we're trying to figure out the distance between the 2 points of the left-right direction, like x, and we're trying to do it for the y, and, just figure out what is the distance between the 2 points with the x and the y. Well, the distance formula, but in space, is like the same thing. The distance will equal x2 minus x1. That's still the same. We're still going to square it. And we're going to find the y2, the second point, minus the y1 of the first point, square it. And then we're going to add this z squared minus z1 and square it. So basically, now we just have 3 points. So now we have to determine the distance between each of the pair of points. So why don't I'll let you do number 3. I'm going to do number 4. Well, I'll do both for you. Let's do 3 and then 4. So looking at this, I know that the distance formula states, hey, look, the distance is equal to, I'm going to take my second point, 2 minus 0 squared plus 4 minus 0 squared plus 3 minus 0 squared. And if we do that, we get 4 plus 16 plus 9. We still have to find the square of that. So the distance of that is going to be the square root of 29. Well, we probably want to figure out what exactly that is. So let's do it. All right, so looking at my calculator, the distance is going to be 5.38 5, 1, 6, and so on, but we'd probably want to just make it 5.39, rounded up. However, when it's written like this, we're not going to want that. Unless, of course, it's a real-world situation, then yeah, we're going to do it. But if it's just pure, these numbers right here, we're not. All right, so let's go on. So let me set this up for you, and I want you to finish it. This distance will equal the square root of, now it doesn't matter which one's first. It doesn't. We could put the 1 first or the 4 first. Now if I do the 1 first, I'm going to see the following happen. Minus 6 squared plus 1 minus 0 squared. I mean, this will become positive. Negatives don't really matter, but like 1 minus 4 is negative 3, but squaring it will be 9. Now go ahead and figure this out, and then I'm going to show you the answer in just a second. All right, so here we go. It's the square root of 46. All right, let's go on. So looking at this, go ahead, I want you to solve this one. It's the same setup, except there's words and stuff. This one's really nice because it starts with the origin, exactly like number 3 right there, but they give you a little bit higher numbers. So if you square 12, that's going to be 144, that sort of thing. All right, now for this one, you are going to have to use the calculator to find the square root of it. All right, let's go on. So, midpoint formula, but in space. So basically, we're trying to figure out, this equation is basically find the midpoint of the x, find the midpoint of the y, between the 2 points. That's it. But the midpoint of the, not distance formula, let's cross it out. Put midpoint formula in space is exactly the same thing, except we add a dimension. So xm, the midpoint of x, and the midpoint of y, and the midpoint of m will equal x1 plus x2 divided by 2, and then add the y's, divide by 2, and then add the z's, and then divide by 2. That's it. Just add the values, divide by 2. Add the values, divide by 2. So if we're going to try to find the midpoint of, for example, m, by joining each pair of points right here, well, all we have to do is we have to do this. Negative 2 plus 4 divided by 2, and then negative 4 plus 2 divided by 2, and then negative 4 plus 0 divided by 2. And then we'll just resolve it. Like, what happens when this happens? Well, looky here. 2 divided by 2 is 1. 2 divided by 2 is 1. Negative 4 divided by 2 is negative 2. So here's our midpoint. So the midpoint is 1, 1, negative 2. That's in between. All right, go ahead and do number 7. And we will go on in 5, 4, 3, 2, 1. All right, guys, here we go. So now we're getting into, hey, find the error. So the rest of this stuff right now is your homework. Go ahead and try your best. Answer each question. You have 8 right here. Figure out who's right, who's right, and explain your reasoning of who is right. And then finally for this one, you have 2 problems. You are going to find, it's actually 4. You're going to find the distance between each point, and you're going to find the midpoint of each point. So, and there's 2 of them. Question 9 and 10 right here. So find the distance of each and find the midpoint of each. All right, guys. Thank you very much. And I'll catch you tomorrow. Bye.